So it turns out I know another grad student who was looking at the acidity of some high mountain lakes, and so it turns out that lakes are said to be non-acidic if the pH exceeds 6. Okay, if the pH exceeds 6, they're said to be non-acidic, and so maybe we'll take as our null hypothesis that the mean acidity of these lakes is 6 or less. Okay, maybe we could use an equal sign or less than or equal to sign there, and then for our alternative, maybe I'm looking to see, maybe I'm trying to see if there's evidence to support this hypothesis that the mean is actually greater than 6. Okay, so this will be called a right-tailed test, because ultimately, you can tell by the symbol there, we'll be looking out into the right tail of our t-distribution to get the p-value. So the first thing I'm going to do, actually, you know what, I haven't been doing a very good job of this, but you should always do this, whether I do it or not. You should always check the assumptions. I think so far we've been okay. With the previous two examples, our sample sizes were pretty decent, so we didn't have to worry about it too much. First of all, simple random sampling. Simple A, random A sampling. Random sampling. Did the grad student take a simple random sample? Well, sure, I guess. I have no way of knowing, but I know this guy. He's pretty good. I'll just assume that was done. In reality, that's a really hard thing to do, but we'll assume that it was done correctly. Okay. These samples were taken not just from the same lake, same day, same time, same place. Okay. They were taken from all over. Next, also, either we need large sample size or data appear somewhat quasi-normal. Okay. By normal, I mean like like they're coming from a bell curve. So, well, first of all, here's if you look on the website at the notes, you'll see this example there. It's called example 6, about acidity of lakes. There are 15 data values. 15 is not very large. Okay, maybe that's all that they could get to. Okay, spent too much time skiing or something. I'm going to put my data values into my calculator. Put these into list 3, okay? And you can find those data values on the website, or you can just get them here. 7.3, 7.2, 6.6, 6.9, 6.1. So far, all these are above 6, right? So the average is going to be above 6. Already, I'm sort of suspicious that, well, there's a 5.7, but it's looking at me like these lakes are non-acidic. Maybe if I'm 7.9, 6.3, 6.7, right? 6.7, I'm going to double check these real quick. 6.7, 6.3, 7.9, 5.8, 6.5, 5.5, 7.3, 5.7, 6.9, 6.3, 6.1, 6.9, 6.6, 7.2, and 7.3. All right. Good. So let's do some one variable stats on list 3. If the mean is 6.6, and sample standard deviation is 0.67188 or so. X bar is 6.6, and the sample standard deviation is about 0.67188. Oh yeah, we were checking assumptions, right? Okay, so we have a couple things that we can look at here. Maybe I'll remember how to make a histogram with your calculator. I'll go into one of these plots, turn it on, press the enter key there, turn it on. I'll make a histogram of this stuff. It's in list 3 there, right? And then to see it, remember you have to hit zoom 9, zoom 9. and sometimes that just doesn't work for me. So sometimes I'll quit. You should never quit, but sometimes I do. Now let's zoom 9. Okay, what do you think? Does that look sort of bell-shaped? Yeah, no, I don't know, sort of. Okay, it's sort of mound-shaped. It's again, it's only 15 values, so it's kind of difficult to ascertain the bell-shapiness from something like that. But yeah, it's sort of mound-shaped, right? A clump there, sort of over there. Also, remember you can make a normal probability plot or a QQ plot, and that's this one here. Remember, it plots the theoretical percentiles against the observed the percentiles from your data. Okay, so good. I'll hit zoom 9. So if this is sort of linear, then we're probably in okay shape. And yeah, it is. That sort of looks straight-liney. So I'm going to say that my assumptions are reasonably satisfied. Okay, because technically here, what I want to say is that there is insufficient evidence to conclude the data are not coming from a normal distribution. Okay, technically that's how you want to say that. There's insufficient evidence to conclude that the data are not coming from a normal distribution. Are they really coming from a normal distribution? Probably not. Probably not. But maybe it's close enough for all this stuff to work. All right. Anyway, now I'm going to get my test statistic, which, again, it's x bar minus mu naught over s over the square root of the sample size, right? So x bar is 6.6. The mu naught is 6, right? This is up here, right? This guy. This is mu naught. It's not mu. Okay. I know this says that mu is 6, but remember, this is just a hypothesis that the actual mean is 6. So mu naught is your sort of the mean suggested by the null hypothesis. And then I'm going to divide this by 0.67188 over the square root of the sample size, 15. So I'll put that in my calculator there. I got 6 minus, oops, I mean 6.6 minus 6 divided by 0.67188 over the squirt of 15. 3.4586. I think, just by looking at that, I think that's probably pretty high. So our p-value, in this case, it's the chance that you would see something that high or higher, right? Because that's what our alternative hypothesis is telling us what tail to look at, in the right tail, right? So 0. I want to know. I'm trying to see if there's sufficient evidence to conclude that the mean is higher than 6, right? So this is 3.4586. I'm looking for this area here. That area right there is our p-value. Okay, and so I get that using that TCDF function. Okay, go from 3.4586 up to, forever, 10 to the 99th or whatever. And then I have to put in my degrees of freedom, which is 14, right? One less than the sample size. Okay, so distribution function, wait a minute, where is it? There it is, option 6. TCDF of 3.4586 up to 10 to the 99th, and then comma 14, right? And there you go, p-values, pretty small, 0.0019. That's small. That's pretty small. That's like 0.2%. So I'm going to say that since the p-value is so small, there appears to be evidence pointing to the hypothesis that mu is greater than 6. Okay? In fact, we can say we can reject the null hypothesis H naught in favor of the alternative H sub A at the 0.0019 level of significance. Okay.